We're going to talk a little bit about ohms now. Ohms is the measurement of resistance, and you can see the little audible symbol next to it. Basically what that does is, if I have continuity between these two probes, it's going to beep, just like this. Okay, that comes in kind of handy for multiple reasons. If your meter's somewhere else and you can't visually watch it, it'll beep. The other thing is, if you notice down on the bottom, you can see the numbers change. That's a measure of resistance across these two leads. 0.1 ohms. It's relatively low, and we're going to show you a couple of these, how to check ohms and basic troubleshooting of a circuit. Okay, this starts the basic troubleshooting. We're going to basically check this switch to see if it's actually working or not. These are the two leads out of the horn button on that switch. We're just going to go ahead and connect these up. You don't want it hooked up to the rest of the bike at this point. You want to isolate this circuit, so that means unplugging and getting on those pins. We're going to turn this up to ohms. Right now nobody's pressing down on the button, so I shouldn't have continuity through the switch, but as soon as somebody presses down on it, I should be completing the path. Okay, you saw that that dropped down to a 0.2 to 0.3 ohms. That's not too bad. When you get in higher resistance, up around 0.5, you really start to have concern. But if I wouldn't have had continuity through that switch, that OL, it means open line or open switch. You want the two pieces of metal inside there to contact each other. If they're open, current can't pass between them. Okay, this is basic troubleshooting on the average electrical circuit. This would be the equivalent of your battery connection right here. We come off that, we come to a fuse. After the fuse, basically gets connected into a switch. You always want to keep the fuse as close to the battery as possible, because that's your circuit protection. This length of wire is unprotected if by chance there's a short. After this, if this does dead short, that fuse will blow. After the fuse, we have a switch. After the switch, we have what we're powering. So right now, I've got this walked up to this circuit. I want to know what's wrong with it. So I've got my negative hooked up to my negative side of my battery right here, and we're going to turn this on voltage DC. I'm going to come over here. I've got 12.7 volts there. That's good. First side of the fuse, 12.7. That's good. Second side of the fuse, 12.7. That's good. After the fuse, I've got 12.7. So now the next step is going into the switch. It comes through to the switch and over to this connection right here. I don't have anything there. That tells me that something's wrong with my switch. Maybe it's not on. Okay, now we check it again. Not only did my lights come on, but I also have 12.6 after the switch now. Every connection up to what the unit is powering should have 12.6. If I put it after these LED lights right here, I don't have any voltage at all. Right here, 12.6. So these lights are consuming that power. Okay, if I wanted to diagnose this switch, what I would do is I would disconnect the two battery cables, which I've done. You can see the negative sides here, and I've got the positive lead off over there. I'm going to connect one side of the switch, then I'm going to connect to the other side of the switch. Or should stay there. Okay, right now, if I put it on ohms, the switch is on. Now the switch is off. Switch is on, 0.2 ohms, 0.3 ohms, switch is off, goes to open line. That switch is good. If I wanted to check this fuse, I put it on ohms, grab one side, grab the other side. Now you can hear that fuse is good. You can also see the little element between the two tabs. That's what will actually burn up if you have a problem in your circuit. Okay, if this was in a circuit, you can see I got my hot lead coming in. This is my fuse. Just after my fuse, maybe before my switch, maybe after my switch, all of a sudden I get a hole in my wire. It rubs up against the frame, it creates a direct short. Now if you look at this real close, you can see part of that's gone. That is what a dead short is. Okay, basically what we're going to do is we're going to check this fuel warning light assembly. This is actually out of a 2005 VTX F, and all it is basically two wires. Completes the path of ground. You can see one wire is terminated to the actual plate, and the other wire is terminated. You can see they're real careful not to get it to touch this plate. It runs all the way down to the sensor here, and what that does is it'll actually pick up when this gets dipped into a liquid. It'll complete the path of ground, and it will actually complete the circuit. Okay, so I'll connect my leads until I've got it in ohms. I've got 17, 13, if I can hold my probes right. I'm going to go ahead and pick this up. You can see just by holding it I'm changing the resistance. When I dump it in the water, I get 4,000 ohms. Now that amount of resistance obviously works in the computer ECU, and the fact that I get a change tells me that this is working. If I had OL or open line through that sensor, I would know that that sensor is defective. You can see here these are 6 different types of meters that we've gone through. They all pretty much work the same. As long as you have voltage, AC, DC, and ohms, there's really not a whole lot you can't check.